Hey everybody, today we are going to be doing our last video for our Unit 2. This one is a little bit of a toughie, so you want to just kind of hold on and get through it, and if you need, I can show you some quick tricks in class on how to make this a little bit easier for you. But I'm going to show you how to do this all algebraically. We're going to find the distance between two parallel lines, and then we're going to find the distance between a point and a line. And the key thing here to remember is to find the distance between two things, especially if they're parallel, the point to the line, it's always going to be the perpendicular distance between the two things. So the first one we're going to do is between the two lines. Again, they're parallel lines. And here's the steps you're going to want to take. Again, write these down. Step one is going to be identifying a point on one of the lines. Now, it doesn't matter which one you choose, what point, as long as it's on one of the lines. But I would always recommend doing the y-intercept because that makes step two a little bit easier for you. Okay. Step number two, find the slope perpendicular to both lines, and you create an equation using the new slope that you've identified and find the point from step one. So think about the last lesson, how you were finding all the perpendicular slopes, and then find the perpendicular lines with that slope using a point. That's what you're doing here. Step three, you're going to find the point of intersection between the equation from step two and the other equation that's in the problem. And step four, find the distance between the 2 points. So right now, you've written this down, and you're like, I have no idea what on earth she's even beginning to talk about. So let me give you a visual on what we're doing. So step one is to identify a point on one of the two lines. So I'm going to choose the lighter blue one here. So if I were to, whoopsies, I got to get my pen out. I'm sorry about that. So what we're going to do is identify, like I said, I like to do the y-intercept. So that's the point that I'm going to point out. This is the point of 0, 7. And that's what I'm going to write down when I start doing these problems. So the next thing I want to do is create the line that's perpendicular to both of these. Since they're parallel, when I create that perpendicular line, it's definitely going to be perpendicular to both. Okay, so let me show that with that right angle. So the step two is finding the equation of the line that I just drew in there. Okay, and I'm going to show you, it's more simple than you think. Step three, this is the hardest step probably of the whole thing, is we're going to find this point of intersection. Now, it's only going to be hard if you do it using algebra. Now, we can do everything on a graphing calculator, and I will show that to you if you ask me to. But you're going to find that point of intersection. And then last but not least, we're going to find the distance between the point that we found over here and the point we found over here. So we're going to find that length using our distance formula. So let's do an example with that. So here are two equations. We got 2/3 x minus 4 and 2/3 x plus 2. We know they are parallel because they have the exact same slopes there. So the first thing I'm going to do is identify a point on one of the lines. And like I said, I'm going to use the first line, but you're going to want to use the y-intercept because it's already identified for you right here. So it's essentially like I identified that y-intercept there. So in this case, though, it's the point 0, -4. Second step is I'm going to find the perpendicular line. Now, like I said, this is actually a really simple. Because this is a y-intercept, it's going to be the y-intercept of this first problem, and it's going to be a y-intercept in our second one. Okay, so the only thing we really need to do is take this 2/3 and find its opposite reciprocal, which is -3/2. And like I said, since it's a y-intercept, it's going to be the y-intercept here. Okay, so you see how that's kind of matching up. So that's what I'm saying, is that wasn't as hard as you might have thought of. So what we did right now is found the line that was perpendicular to the two lines. Okay, they're going to share that y-intercept right there. All right, step three is going to find that point of intersection. Again, we're looking for that point of intersection right there. Again, this is where it gets tough because I'm going to show it to you using algebra. So we have ways to solve a system in the past. You solved it through substitution, elimination, and graphing. So if you really wanted to, you could graph, but you're not going to get a really exact answer unless you're using a graphing calculator. So doing it using substitution, I'm going to set the two things equal to each other. We'll do that in a second. So what I mean by that is I'm going to take this equation that I just came up with, and I have to use the second equation. Because if I use the first one, I'm just refinding this point right here, and I don't want that, okay? So I'm going to set those two things equal to each other. I always like to get rid of a fraction. So what I see is I have two denominators, a 2 and a 3. So in order to get rid of those at the same exact time, I'm going to multiply both of those by 6. Because when I distribute this 6 to this first piece here, 6 times -3 divided by 2 is going to get rid of the denominator. And when I do 6 times the 2/3, the 6 and the 3 are going to cancel out with a 3 and the 6. Okay, so that's going to cancel out, giving us some whole numbers. So 6 times -3 is -18, divided by 2 is -9. We have -24. 6 times 2 is 12, divided by 3 is 4. plus the 12. Okay, so you see it, nothing canceled out with 6 times negative 4. All right, now we're back at algebra where our goal is to get x's on one side, numbers on the other. So I'm going to move the x's to the right. Doesn't really matter which way you decide to go. Before, and we're going to end up adding 9 to the 4x and subtracting 12 from negative 24. So I get 13x equals negative 36. Dividing both sides, and I do get a decimal. So this is where things get tricky because you're going to get a lot of decimals here. So just go at least 2 decimal places. The more decimal places you go, the more accurate it is. All right, so for here, I have my x value. My goal is to find the y value. I actually have 2 equations I can use. I can use this one here, the second equation, or I can use this one. I'm just going to continue to use this equation that I have. And I'm going to substitute that negative 2.77 right in here for that x. Okay, so I see I have it in red. So I'm going to multiply negative 3/2 times the negative 2.77. I'm just going to plug and chug, and I'm going to subtract the 4, and I get 0.55. And that's the number you should be getting. Again, I believe that is a rounded number. So I've got the equation. I have an x value here. Here's my y value. And now I can come up with a coordinate. So that's this one right here, the negative 2.77, comma 0.155. So there's a coordinate here, and there's a coordinate that I found right here. So the -4 would be like the y-intercepts from here. The second equation I found is the point of intersection here. So my goal is to find what is the distance between these two here. So my last thing is going to be using those 2 points and finding the distance between them. So I'm going to do 0 minus negative 2.77, which is the same thing as saying 0 plus, and then -4 minus 0.155. And when I plug and chug that into my calculator, I get about 4.99. Again, we like to go about 2 decimal places. If you said 5, it's not the end of the world, but that's kind of the idea behind it. Okay? So here's our first example. That's between 2 lines. My next one is going to be from a point to a line. So here's our steps. From this one, I'm giving you a point already, so I don't have to do step 1 like I did in the last one. Instead, I'm going to find the equation of a line perpendicular to the line given through the given point. So again, it's a lot like the problems that you saw in the very last thing. Sorry about that. My phone was going off. All right, second step we're going to be doing is very similar to the other ones. We're going to find the point of intersection between the 2 lines that you have created, and then finally you're going to find the distance. So steps 2 and 3 are pretty much the same as the steps 3 and 4 in the last one. Step 1 and 2 is kind of combined into this step 1 here. All right, so again, what am I talking about? Since I don't have a line coming across here, I'm just given the single point here. All I need to do is find that line that's perpendicular. Okay, so that's going to be perpendicular, and then find where it's intersecting here. And then I'm going to find the distance from the point that I was given to the point that I find at the point of intersection. So let's look at an example here. I have the point 86, and we're going to the line y equals negative 1/4 x plus 2. So again, first step is finding the perpendicular line through that point. So this one's a little bit more involved. You're going to have to think about to that last lesson where we're going to do that point slope form, the y minus y1 equals m times x minus x1, and making sure that instead of using the 1/4, we're using the opposite reciprocal, which is 4. So it's y minus 6 because it's y minus y, and the y value is 6. Equals 4 times x minus 8. So I'm going to distribute the 4 and move the 6 over, and I end up with y equals 4x minus 26. If you are still having trouble here, please make sure you're getting some help. Okay, so what I've done right now, and again, this is not the exact problem, but I'm just kind of relating it back, is I found the line that's going this way. That's my whole point, was to find that line that was perpendicular to the line that was given to you through the point that was given to you. So now my next step is going to be finding that point of intersection. Again, we're going to go back to doing the algebraic way. Again, I will be happy to show you how to do it on your graphing calculator, but make sure you get this all done and written down first so you have it as a reference, and then I'll show you how to do it if you have a graphing calculator. Anyways, now we only really have 2 equations to work off of. We have the y equals 4x minus 26, and we have the first equation that was given to us up here at the top. And so those are the 2 I'm going to set equals to each other because they both say y equals. Now, as you can see here, only one of them has a fraction, so I'm going to get rid of it by multiplying that whole thing now by 4. Now, when I distribute through with the 4, it's not really going to cancel anything out. My goal was really to cancel some things out when I hit that third piece there. So making sure we're going through the whole entire thing with distributing. 4 times 4 is 16. 4 times negative 26 is negative 104. 4 times negative 1 is negative 4, divided by 4 is negative 1, and then 4 times 2 is 8. So I'm going to move my 16x to the right, and I'm going to move my 8 to the left, and I get negative 112 equals negative 17x, and when I divide, I get about 6.59. Remember, I'm going to take that, I'm going to substitute it back in. Now, I like to avoid fractions. So I'm going to use the equation that I have right here. Okay, and I have y equals 4 times the x value I just found minus this 26. And I'm going to plug and chug and I get 0.36. Again, that process that I'm doing is finding what is that point of intersection between these two lines. So my last step is, well, I've had this point and now I just found this point. I'm going to find the distance between those 2 points. Okay, so I have my x value and y value to get my coordinate here, and then I have this coordinate, what happened there? And then I have this coordinate given to me in the beginning. So I'm going to find the distance between those 2 points. So 8 minus 6.59 squared plus 6 minus 0.36 squared, and find the distance. And so this again, plug and chug into that lovely calculator of yours, and we get about 5.89. Again, a nice rule of thumb is to go to at least 2 decimal places. So you'll get a lot of practice on this. Please, again, I know this is a little bit tough to comprehend for some of you, so please make sure you're getting some assistance, as this is our last one, so usually it's the most difficult lesson. I hope you have a good handle on it, though. If not, like I said, let us know.